Have you ever pondered about what defines the state of a system? Well, today we're going to unravel the mysteries of thermodynamics, starting with the concept of system and surroundings. Imagine you're studying the behavior of gas inside a piston cylinder arrangement. In this scenario, the gas you're interested in is the system. Everything else, including the cylinder walls, constitute the surroundings. Essentially, a system is a specific portion of space chosen for study, while everything outside that space is the surroundings. Now, to describe a system, we use certain characteristics known as properties. For instance, if the system is a gas, its properties would include pressure, volume, and temperature. These properties are crucial because they define the state of the system. Let's say you have a gas at 300 Kelvin, 1 atmosphere, and occupying a volume of 2 liters. These values are not just random numbers, they define the state of the gas. But systems don't exist in a vacuum. They interact with their surroundings, leading to changes in their state. These changes are what we refer to as processes. For example, if you heat a gas at constant pressure, the gas undergoes an isobaric process. Now that we've covered systems, properties, and processes, let's delve into the laws of thermodynamics. The Zeroth law, quite intriguingly named, states that if 2 systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. In simpler words, if 2 cups of coffee are each at the same temperature as a third cup, then the 2 cups are at the same temperature. Moving on, the first law of thermodynamics is essentially the principle of conservation of energy. It asserts that energy cannot be created or destroyed, only transferred or converted from one form to another. Think of burning fuel in an engine. The chemical energy of the fuel is not destroyed. Instead, it's converted into mechanical work and heat. The second law of thermodynamics is all about entropy. It states that the total entropy of an isolated system can only increase over time. For instance, heat naturally flows from a hot object to a cold one, increasing the overall entropy of the system. Finally, the third law of thermodynamics tells us that as the temperature of a system approaches absolute zero, the entropy approaches a minimum constant value. In other words, at absolute zero, a perfectly ordered crystal would have minimum entropy. In summary, thermodynamics is the study of systems, their properties, their states, the processes they undergo, and the laws that govern these processes. It's a fascinating field that helps us understand the natural world, from the behavior of gases in a cylinder to the flow of energy in an engine. So the next time you sip a hot cup of coffee or marvel at a running engine, remember the intriguing principles of thermodynamics at play.